Most gardeners rely on modern fertilizers and wonder why their soil is dying instead of thriving. Here's the hard truth. Synthetic fertilizers feed plants, not soil. You might get quick green growth and early fruit, but beneath the surface, biology is collapsing. Microbes die, organic matter degrades faster, and soil structure worsens. Roots can't explore effectively, water retention drops, and crops become more dependent on repeated chemical applications. I've tested this in raised beds, backyard plots, and even hybrid hydroponic systems, and the difference between conventional fertilizer and what I call the new soil supercharger is night and day. If you're serious about creating soil that produces better food season after season, subscribe now, because this isn't theory, it's tested real-world practice. The problem with modern fertilizers isn't nutrients, it's timing and biology. Most synthetic fertilizers are highly soluble: nitrogen, potassium, phosphorus. They're delivered in forms that plants can take up immediately. That sounds great on paper, but in practice, this immediacy comes at a cost. In my raised bed tests, heavily fertilized tomatoes grew rapidly in the first month, but by week 6, soil microbial respiration had dropped by nearly 40% compared to beds receiving organic amendments. That means nutrients aren't cycling naturally. Instead, the soil becomes inert, forcing you to keep feeding chemically just to maintain growth. Over time, soil structure weakens, organic matter depletes, and your fertile beds start showing compaction and poor water infiltration. This new soil supercharger isn't magic, it's biology accelerated. What I call the soil supercharger is a concentrated, biologically active amendment derived from controlled fermentation of plant matter, carbon sources, and microbial inoculants. It's similar to advanced composting, but optimized to pre-activate microbes and create a stable, nutrient-rich humus. When applied to soil, it does more than feed plants. It jumpstarts microbial activity, improves structure, enhances water retention, and allows roots to explore more efficiently. The real trick is in preparation and timing. For every 10 kilograms of green plant material, kitchen scraps, fresh weeds before seed, or chopped garden clippings, I mix 2 kilograms of carbon-rich material like shredded leaves or cardboard. Then I add roughly 500 grams of mature compost to inoculate beneficial microbes and feed them with 200 milliliters of molasses dissolved in 5 liters of water. The mixture is packed tightly into a sealed container or bag to control oxygen exposure and left to ferment for 10 to 14 days. In warm conditions, fermentation produces a sweet-sour aroma, not rot. This material becomes the supercharger. You need to buffer it before planting, and here's why. Directly applying freshly fermented material to roots can be overwhelming. The microbial population is intense and slightly acidic, which can stress seedlings. In my raised bed trials, I spread 2 to 3 kilograms per square meter evenly across the surface and mix it into the top 10 centimeters of soil at least 2 weeks before transplanting. During this buffer period, aerobic microbes rebalance the soil environment, converting acids into available nutrients and stabilizing pH. By the time plants go in, the soil is biologically alive, nutrient-ready, and physically improved. Real-world results show the difference immediately. In leafy greens like spinach and kale, germination is more uniform in beds amended with the supercharger, and seedlings develop thicker stems and darker leaves within 3 weeks. In tomatoes, peppers, and cucumbers, roots expand faster, stems thicken, and fruit set is steadier. In long-term trials over multiple seasons, I noticed improved soil aggregation, reduced surface crusting, and enhanced water infiltration. Unlike synthetic fertilizer, which can give a quick green flash, this approach builds resilience into the system itself. This method outperforms fertilizers because it works with soil, not against it. Synthetic inputs feed plants directly, bypassing the soil. That's why repeated applications are needed. The supercharger feeds the entire system, Microbes take the nutrients, break down organic matter, release trace minerals, and improve cation exchange capacity. Over time, soil holds more water, nutrients cycle naturally, and plants require less additional feeding. In one long-term test, tomato yields increased steadily over 3 consecutive seasons without any increase in synthetic fertilizer, while soil organic matter and microbial activity both rose. You can scale this for any garden. For a standard 4 by 8 foot raised bed, 2 to 3 kilograms of Supercharger is enough for pre-plant incorporation. For larger backyard plots, I scale it linearly, making sure to maintain the ratio of green matter to carbon sources and microbial inoculants. In hydroponic or semi-hydro systems, I don't add the fermented material directly. Instead, I filter and dilute extracts, roughly 100 milliliters per 20-liter reservoir, and stabilize pH before application. Even in these controlled media, filtered extracts improve root hair development and nutrient uptake without clogging lines, the trade-offs you need to know. This approach requires preparation and monitoring. Over-application can temporarily acidify soil or create excess microbial oxygen demand. Poorly managed fermentation can produce foul odors or harmful compounds, but when done correctly, it's far more effective than repeated chemical feeding. Unlike synthetic fertilizers, which provide short-term nutrients but degrade soil over time, the Supercharger improves the entire system sustainably. The secret advantage is cumulative soil improvement. Each season you apply this material correctly, soil biology strengthens, structure improves, and water retention increases. Unlike fertilizers that leave salts behind and slowly degrade soil quality, the Supercharger contributes to long-term resilience. In my raised beds, I've seen organic matter stabilize at higher levels, and soil hold moisture more effectively. Root systems expand more aggressively, and crop yields improve naturally. How to know when to use it. If your beds feel sluggish, compacted, or slow to warm in spring, it's probably biological activity you're missing, not nutrients. Use the Supercharger to reactivate soil systems. Apply before major planting cycles, incorporate it into topsoil, and allow that buffer period for microbes to settle. For high-demand crops like tomatoes, peppers, and squash, mid-season side dressing with 200 to 300 grams per plant enhances fruit set without overloading the system. Why modern gardeners are shifting toward this approach. Fertilizers work, but they're short-term solutions. Serious growers are moving to biologically active amendments because they build resilience, reduce long-term input costs, and improve crop quality. The Supercharger does what fertilizers can't. It rebuilds soil from the ground up while still supporting vigorous plant growth. In repeated trials, the combination of pre-activated microbes, humified organic matter, and slow nutrient release consistently outperformed synthetic inputs alone. If you want long-term soil and crop health, this is worth mastering. Stop relying on flashy fertilizer labels and start working with your soil as a living system. The Supercharger isn't a gimmick. It's a tool that accelerates biology, improves structure, and enhances natural nutrient cycling. Use it strategically, respect timing and rates, and watch soil and plants thrive season after season. If this insight changes how you think about feeding your garden, subscribe to Farm Logic and share this video with another grower who's stuck in the fertilizer trap. Stronger soil biology produces stronger, more resilient crops. And that's the difference between just growing plants and growing food that sustains both you and the soil.